Hey everyone, and welcome back to our playlist on Spring RestClient, setup, headers, query params, and timeouts. Today, I'm going to put my senior tech lead hat on and walk you through exactly how to elegantly and most importantly, safely handle building URIs. Now, if you've been following along in this course, you already know how to configure your basic client. So it's time to actually start making those calls. But before we even type a single line of code, we really have to ask ourselves a fundamental question. How do we avoid those nasty string concatenation bugs? You know exactly the ones I'm talking about, the code that completely breaks the moment a URL contains a space, an ampersand, or an equal sign. We want our apps to be bulletproof, right? And letting the framework handle our URL encoding is the absolute first step. So here's our roadmap for this explainer today. 1. The post data model. 2. Single query parameters. 3. Multiple query parameters. 4. Using path variables. 5. Generics and type erasure. And we'll wrap it up with 6. Summary and best practices. Let's just dive right in. Section 1. The post data model. First things first, before we can fetch any data, we need to set the exact foundation for what we'll be reading our API responses into. Take a look at this post.java file. It's so incredibly clean, isn't it? This is just a perfect use case for a Java record. We literally just declare public record post and toss 4 simple fields right in the parentheses: long ID, long user ID, string title, and string body. And that is it. No getters, no setters, completely keeping our code free of all that boilerplate nonsense. And the real beauty here is how Jackson handles this. It automatically maps those exact JSON keys straight onto our record components by name. Since our API returns JSON with ID, user ID, title, and body, Jackson just sees this record and makes the deserialization completely seamless. Keep this shape in mind, because this is the exact object we're going to be working with moving forward. All right, Section 2, Single Query Parameters. Now that our model is perfectly shaped, let's jump straight into our service class and make our very first API call. If we peek inside our post service class here, notice in the constructor how Spring handles the dependency injection for our REST-client bean. We just pass in REST-client JSON placeholder REST-client, assign it to our private final field, and boom, we are perfectly prepped to use our getPostsByUser method right below it. Let's break down that getPostsByUser method line by line, because this flow is super crucial. We return RESTClient.get. Then step 1, we use .URI with a UriBuilder lambda. So we write UriBuilder arrow UriBuilder.path/posts .queryParam userid.build. That safely tacks on our user ID. Step 2 calls .retrieve to actually fire the request off. And finally, step 3 uses .body passing in postListType to deserialize the response right into a list. Beautiful, right? Moving right along to Section 3, Multiple Query Parameters. Let's see how this builds when we need more than one query parameter in our URL. Because honestly, when does a real-world API ever just ask for one thing? In the search post method of our service class, we're taking in a long user ID and a string title like. If we need multiple query parameters, we simply chain .queryParam as many times as we need right inside that UriBuilder lambda. Literally, it's .queryParam user ID, directly followed by .queryParam title like. No messy hand-coded ampersands required on our end. The builder handles the whole shebang safely. Okay, Section 4, Using Path Variables. So what happens when our endpoint dictates that we use a path variable instead of a query parameter string? Say we just want one specific post by its ID. For our getPost method, we actually don't need that whole URIBuilder lambda. Instead, we use the much simpler template style. We just call .URI, pass the strings /post/ID, and then follow it with the ID variable. Spring automatically finds those curly braces, drops the value in, and URL encodes it for you. Then we just hit .retrieve, and since it's a single object this time, we call .body passing in post.class. So here is the golden rule for keeping your code clean. Pick the right flavor. Use the template style, like /posts/ID, when you're dealing with path variables. But the second we'll need to construct dynamic query parameters or optional segments, switch over and use that UriBuilder style. Section 5, Generics and Type Erasure. We need to talk about a really subtle Java computer science quirk that was actually hiding in plain sight in our very first getPostsByUser method. You might have noticed earlier that when we wanted a single post, we easily wrote post.class in the body method. But when we want a list of posts back, why on earth can't we just write list square bracket post.class inside our .body call to deserialize the array? Well, blame Java's type erasure. At runtime, Java completely drops that generic type data. That means that specific class literal list-of-posts.class literally doesn't exist when the code is running. So to get around this, we have to use a parameterized type reference to capture that full generic type so the deserializer knows exactly what it's building. And as a quick pro tip on how to implement this efficiently, if you look at the very top of our post service class, we cached this token as a private static final parameterized type reference list of posts, post list type. Doing this actually creates an anonymous subclass under the hood, so making sure we cache it means we aren't wasting memory spinning up a fresh instance on every single API call. It's a small detail, but hey, performance matters. Finally, Section 6, Summary and Best Practices. You guys have done great following along so far. Let's cement those unbreakable rules for Spring RestClient URIs. If you take away just one thing today, let it be this. Absolutely never hand concatenate values into a URL like strings with plus signs. Please don't do /posts user ID equals user ID. That is just a disaster waiting to happen the second someone's username has a space in it. Always use URI templates or UriBuilder and let the framework encode it automatically to prevent those nasty injection bugs. To quickly sum up our lesson today, we modeled our JSON safely with a clean Java record. We utilized the UriBuilder Lambda for handling our single and multiple query params. We leveraged URI templates for path variables. And we easily beat Java's type erasure using a cached parameterized type reference. This setup is going to make your API calls so much more robust. Be sure to check out the detailed article link in the description below for the full code base we reviewed today, and definitely stick around for the next part of this course where we are going to master multiple headers per request. Until then, ask yourself, are there any hidden string concatenations lurking in your legacy microservices right now? Go check your code, keep coding, and I'll see you in the next one.